Okay, now we're into chapter 1 of the light and sound unit, which is all about waves. Okay, section 1 deals with the nature of waves. First of all, we want to remind you that waves carry energy. Okay, so by definition, a wave can be described as a disturbance that transmits energy through matter or space. Okay, some waves are going to be able to do both, travel through matter and space. Some, however, are not. Number 2 reminds us that waves travel, the material does not. And think about that. The water is going to go up and down, say, in the ocean, but not all the water goes moving with the wave itself. If it did, the oceans would be empty and all the water would go crashing into the land and flood everything. And obviously that wouldn't be a good thing. Okay, the wave does the work on our water example, making it rise and fall and circle back. But the wave continues on, or the energy continues on, the water basically stays put. Okay, this leads us to then talking about how energy moves through a medium. So first we need to define what a medium is. A lot of times we talk about these when we talk about art. You might do something in, building something out of clay. That's one type of medium. Or using oil paints on a canvas is another type of medium. Okay? In science here, when we're talking about this, a medium is a substance through which a wave travels. So generally we talk about these as solid, liquid, or gas. Okay? Particles are going to vibrate and pass to the next particle. So what that means is, energy, if we talked before, it's neither created or destroyed, it's just merely transferred from one thing to the next. So, for example, as I'm talking into this microphone, I'm creating a wave produced by air going over my vocal cords, which is creating a sound that we call words, into this microphone, which is being recorded, and then those waves are being transferred um, through the computer to you, to your ears and your eardrum, and so on and so forth. Okay, so that's all energy that's being transferred in one way, shape, or form. Okay, mechanical waves, by example, all right, they require a medium, and we have it capitalized mechanical because that's one of the major types of waves that we want to discuss. Sound is the biggest one that we talk about when we talk about mechanical waves. Okay, sound has to have a medium. It has to have something like, say, air molecules to bounce around to be able to transfer. Okay, what does that mean? Well, if we were in outer space or there was a vacuum, I could be standing 2 inches from your ear and scream at the top of my lungs, and you would never be able to hear me. Okay, because there is no medium there for those sound waves to travel through. Okay, energy transfer without a medium. These deal with electromagnetic waves. And again, electromagnetic we talked a little bit about when we did telescopes in the last unit. These do not require a medium. Okay, so that means they can travel through outer space. So for example, light. Obviously that's a good thing. If the sun's light wasn't able to make it through space and get to our planet, life wouldn't exist. Okay, other examples though, microwaves. TV, which is important. That's how we're able to beam things from here up to satellites and pass them to, say, your house through DirecTV or Dish Network or whatever. Radio works the same way. X-rays are another example. Okay, and there are a few more. Again, just because they don't necessarily need a medium doesn't mean that they can't travel through something. So number 2 tells us they can travel through substances, which is good. Okay, we want them to be able to travel through air, like, say, a radio or your TV, so we can get it to your house. But they do tend to move a little bit faster through an empty space. Okay, some waves actually travel faster through, say, a solid medium than they will the air, and we'll talk more about those later. Let's talk about types of waves now. Okay? So we kind of have the two major classification. We have those that need a medium called mechanical, those that don't called electromagnetic. Okay, so let's talk about the types of waves that we find in those categories. First one is a transverse wave. This is where particles are going to vibrate up and down. So let's say I tie a rope to the doorknob and I start moving my arm up and down, creating a wave. Okay, and more than likely this is the type of thing that you would have drawn if I asked you to draw a wave on a piece of paper, that kind of up and down movement. Okay, now one thing letter B tells us is they move perpendicular to the wave. And what we mean there is if I'm moving up and down and creating this wave, but the wave is going to travel, say, from my arm in that rope definition to the doorknob. Okay, so it's moving perpendicular, right, or at a 90-degree angle to the motion that I'm creating. I'm creating an up and down motion, but that wave is going to travel from, say, left to right. Okay. All electromagnetic waves, and again, that's capitalized to emphasize, all electromagnetic waves are transverse waves. Longitudinal waves are when particles vibrate back and forth along the path of a wave. So again, back and forth motion, like in, say, like if you took a slinky and pulled it straight back and then let it go. Okay. Compression is when those particles are close together. When they relax or spread further apart, that's called a rarefaction. The type of waves that move in this manner are sound waves, or one type of wave are sound waves. Okay, and think about it. If you've ever seen like a speaker that's playing music and we talk about it thumping back and forth, and you can see that speaker kind of bouncing back and forth, it's because it's producing those longitudinal waves. The last kind of wave then is the combination wave that are called surface waves. Okay, and they get their name because they generally occur on the surface of things because it's when there is a boundary between two different types of media. Ocean waves, for example, travel this way. Okay. The two media that that ocean wave is touching is going to be the water and the air. Okay. So the wave is rolling along, it's going up and down, much like a transverse wave. But if you've ever stood and you feel the water go past you and then it feels like it kind of pulls back a little bit, okay, in a circular motion, that's that longitudinal wave wanting to work as well. Okay, so the particles tend to move and feel and give that feel of a circular motion. Okay, so they're going to be like little letter I here tells us that forward to the crest and backwards at the trough. Okay, so again, they're called surface waves because they generally occur on a surface between two different media. That's the end of section 1. Make sure you complete your worksheet. We'll see you soon.